Hi guys, this is a video on the remainder and factor theorems. This is linked to long division, and it's actually a shortcut for us to use when we're trying to find remainders and factors of polynomials, and we don't want to go through the whole long division process. Okay, so the first thing I'll start off with is the remainder theorem, okay, which states that's this here. To find the remainder when a polynomial is divided by x minus a, you find P of A. Okay, so what that means is if I want to find the remainder of, say, this one over here, let's just go to this one in terms of this. Okay, so I've got a polynomial here, and I want to divide it by this factor here. I could go through the whole process of doing the long division, but what this is saying is, okay, to find the remainder, I want to divide this by this. I simply put in, okay, so x minus a equates to finding, substituting in x for p of a here. Okay, so if this is x minus a here, we substitute in the negative of that. Okay, so what's p of 2? Okay, so what that means, if you remember correctly, we substitute in 2 where we have x. Okay, so let's do that now. P of x, well, let's do p of 2. So using this equation here, this polynomial, I'm going to put in 2 wherever I say x. Okay, so 2 cubed minus 3 times 2 squared. I'm putting brackets where I'm multiplying by 2, minus 4. Okay, so 2 cubed is 8, minus 3 times 4 is minus 12, plus 6 times 2 is 12, minus 4. Alright, negative 12 plus 12 cancels out, and 8 minus 4 is 4. Okay, so what this has done is saved us all the time of doing that long division algorithm. So, for example, if we were just trying to find the remainder when one polynomial is divided by something else, you don't have to do long division. You can simply go and substitute in the negative of the factor there, and you'll get your result, your remainder. Okay, no good if you're trying to find out what the two factors are, but good if you're just trying to find the remainder. Okay, so that's the factor theorem. All right, so the tricky part of this is that you have to sub in the negative of minus a, which in this case is positive a. If it was positive, it would be negative, into x. Okay, so that's the rule. That is the remainder theorem. Okay, now also we have this, which follows on from the remainder theorem, something called the factor theorem. All right, and if you remember correctly, we're talking about when you do long division and you get to the end and you have no remainder, you're going to have a factor. Okay, so that x minus whatever is a factor of that polynomial. Okay, so what it states is if p of a equals 0, so if the remainder is 0, then x minus a is going to be a factor. Okay, and that sort of follows on from what we just were looking at before. So we can use this tool to find factors of p of x without going through the long division process. Okay, so I'll show you what I mean. All right, so sometimes this is a bit of trial and error. Find a linear factor of this polynomial here. Okay, so let's start with some. Usually, when you're doing this, you're not really given any numbers to go on, but small numbers are better to work with. So let's sort of think about this linear factor here, x plus 1. Okay, is that a factor of this polynomial? The way we find out is we take the negative of that, okay, take negative of that number, okay, so the negative of positive 1 is negative 1. Okay, so what we're going to do is substitute in p negative 1, okay, using this polynomial. So wherever I see x, I'm going to substitute in negative 1. Okay, so let's do that now. So negative 1 all squared plus negative 1 squared, sorry, cubed it was at the start, minus 3 times negative 1 minus 6. Okay, so let's work that out. Negative 1 cubed is negative 1, plus negative 1 squared is 1. minus 3 times negative 1. So that's a negative minus a negative number. So that's going to be plus 3 minus 6. Okay, so these two cancel out. 3 minus 6 is negative 3. Okay, now that is not equal to 0. Not equal to 0. Therefore, remember we said x plus 1 is not a factor of p of x. Okay, so if you start with small numbers, it can be relatively easy to work out. That is a hell of a lot easier than doing the the long division method. Okay, of finding a factor. Okay, so if we are looking for a factor, we should try something different. So let's actually know this one because it is in the example. But say let's work out. Let's see if we find, is that a factor? Okay, is this a factor of p of x? Okay, so again we take the negative. So we're going to do p of negative 2. Okay, p of negative 2. Now I've just checked and the example does tell me that this is not the answer, but we'll go through it anyway because it's good practice. Okay, so you substitute in all these numbers again. Negative 2 minus 3 times negative 2 minus 6. Okay, that's going to be negative 8. Positive 4. Positive 4 plus 6 minus 6. That cancels out. That's going to be positive 4. So that's not a factor either. Okay, so not equal to 0, not a factor. Alright, I'm going to try one more. Okay, let's try x minus 2. Is x minus 2, is it a factor? Alright, so in this case we substitute in p positive 2. Alright, let's just go through this. Okay, so let's find out. In this case we're substituting in 2 for x. Positive numbers are always easier. Okay, so 2 cubed is 8 plus 4 minus 6 minus 6. Okay, so what you might see here is 8 plus 4 is 12, minus 6 is 6, minus 6 is 0. Okay, so that is, it is equal to 0. So it is a factor. So therefore, we use these 3 little dots, therefore x minus 2, remember we said that that's the is a factor. Okay, so this is a good way to work out, and it seems like a lot of trial and error, but if you start with small numbers, okay, so the trick with this one is to check small factors first. Okay, so e.g. x minus 1, x plus 1, x minus 2, x plus 2. Okay, so they work best for these ones because they're easier to work out. Okay, so that's how you find a factor. Often you'll have to, in a couple of classes' time, we will be finding a factor and using that factor to long divide to find a linear factor and a quadratic, and then you go again, you divide again. Okay, so you fully factorize these cubics. Okay, so that is the remainder and the factor theorem.